Hey, it's Mr. Redstone, and in this video we're going to be talking about function notation. Function notation is just another way of saying why. You have a function, it takes x as an input, and then you evaluate it. So we pronounce this f bracket x, f of x. In this first example, we're finding f of 10, meaning we're going to take the function f, and we're going to evaluate it at a value of x equals 10. And then we're going to see what the function value would be. So we start by writing the function f. And we're going to replace the input x with a 10. 3 times 10 plus 4, order of operations, and we'll get 34. If we were to write this as an ordered pair, it would be 1034. It just means when x is 10, y would be plotted as 34. For the second question, h of negative 2. So we are going to evaluate the function h, which is represented by the expression 3x squared, when x is equal to negative 2. So we replace x with a negative 2, and we evaluate that expression. Negative 2 quantity squared is 4. 3 times 4 is 12. So for the function h, when your input is negative 2, your output is 12. Written as an ordered pair, it would be negative 2 comma 12. That's it. For the third question, it's a little bit different, but we want to see when the two functions f and g are the same. And what we're going to get for this is an input. Some value of x will make these two functions equal. So on the left-hand side, we're going to write the expression for f, and on the right, we're going to write the expression for g. And then we would solve this like we would any other equation. And I see that I forgot a 5. It should have been 5x. And there we go. So we subtract 4 from each side to get 5x is negative 5, and divide to get x equals negative 1. So if we did this right, if we were to substitute negative 1 into both f and g, we'll get the same result. And I'm going to do that just to check our work. 3 times negative 1 plus 4 is 1. And then we'll evaluate g at negative 1. That would be negative 2 times negative 1, which is 2. Subtract 1 more is 1. And sure enough, the two functions are both equal to 1 for the input of negative 1. Now, I'm going to do two different examples. This time, I'm not giving you the input. I'm not giving you x. Instead, what I'm giving you is a function value. So what we have to do is find the value of x that makes the expression equal to 16. So 16 is equal to 3x plus 4. Subtract 4 from each side, and then divide by 3. X is equal to 4. So for an input of 4, the value of the function would be 16. Written as an ordered pair, 4 comma 16. And the last question is very similar. We want to find what input makes the function g equal 0. So we start by writing g of x equals negative 2x minus 1. And we're going to substitute the output of 0. So 0 equals negative 2x subtract 1. We add 1 to each side. And then we divide by negative 2. X equals negative 1/2. So for the function g, not f, for g evaluated at negative 1/2, the output would be 0. Or as an ordered pair, negative 1/2 comma 0. That's it. Don't forget, function notation, it's just a fancy way of saying y. Thanks for watching.